Good morning. This is a class on engineering mechanics, and today I'll discuss a problem on statics. Chapter is parallel forces. Here I am starting with a problem. Here in this problem, there is a beam like this, horizontal. It is horizontal. And two supports, simple supports, two supports are there at the ends of the beam. Two ends are there, this end and this end. Okay. So this is horizontal. And there are two simple supports at both the ends. And you know that to simplify the problem, you assume this beam to be weightless. It is just to simplify the problem. You assume this beam to be weightless as compared to the loads which will be kept on this beam. Okay? This beam you need not to consider the weight of this beam. Okay, and say bricks are kept, bricks are kept one by one on the beam. Here there is one brick, by the side of this there is another brick, again there is another brick, like this. Say for example, on this beam there are total 10 bricks and in between the bricks there is no gap. Okay. Say each brick is having a mass of 5 kg and there are 10 bricks, and on this first row of bricks there is another row, then there is another row. Say for example, for this case you assume there are 6 rows, total 6 rows. So how many bricks are there? 10 in a row, and then there is 6 rows. So 6 into 10, that means there are a total of 60 bricks. Then what is the total mass? 60 multiplied by 5. 5 kg is the mass of one brick. 60 into 5, that is 300. 300 kg. Then what is the weight? This total mass multiplied by g. G is 9.8 meter per second square. Okay. So 300 into g, this is the weight in Newton, which is acting in the vertically downward direction, right? Weight of this entire mass, weight of these 60 bricks is acting in the downward direction. And from where? It will be acting through the center of gravity of the entire mass. And you know that center of gravity will be just will pass through the midpoint of this beam. Midpoint, somewhere here, the center of gravity will pass. Okay? That is also vertical. Now suppose this end is denoted by A, this end is denoted by B. So reaction here is denoted by RA and reaction here is denoted by RB, and they will be acting in the vertically upward direction. And this is the problem on statics. The beam is in static condition, it is not moving. Therefore, resultant force acting on the beam must be 0. If you draw the free body diagram of this beam, so you draw a straight line, a horizontal line, then you show two reactions, RA and RB, okay, in the vertical upward direction, and through the midpoint of that line, you draw a downward line, arrow sign, in the downward direction, okay. Put the arrow sign in the downward direction, and that is the weight. Weight is how much? It is 300 into G. With respect to this, the midline, the problem is symmetric. So you can easily say that RA should be equal to RB. Right? So RA is equal to RB. Therefore, what is RA? It is equal to the total weight 300G divided by 2. So 150G. RB is equal to same thing. It is also 150G. So this way this problem can be solved. So shape of the distributed load. This load is distributed over the span of the beam, over the length of the beam. So this is a case on distributed load or distributed force, right? So just by observing the symmetricity of the problem with respect to the mid vertical line, without calculation we can easily say that RA should be equal to RB, therefore it should be equal to 300G by 2, that is 150G. Again the same problem can be solved this way also. RA plus RB is equal to 300G. This is equation number 1. Two unknowns are there, RA and RB. So one more equation is required to solve the given problem. Which is that equation? From where we will get that equation? You know that since the beam is in static condition, it is not moving, so resultant force is 0. Again, it is not rotating, so torque is 0, or moment of the forces about any chosen point must be 0. Moment of the forces. How many forces are acting together on the beam? 3 forces. Through the center of gravity, that weight of the entire mass is acting in the downward direction, that is one force, and RA, RB are the other 2 forces. So total 3 forces are there. And if you take the algebraic summation of the moments, then that moment, that algebraic summation must be 0 since the beam is not rotating. So using that condition, you will get another equation. Now, we will get 2 equations in hand relating RA and RB, so you can solve easily to get the values of RA and RB. So, point is your choice about which you want to calculate the moment. But the smart choice is if you take point either at the point A or either at the point B. If you take the moment at the point A, you calculate moment above point A. So, what is the perpendicular distance of the reaction RA and point A? The perpendicular distance between point A and reaction RA is 0. So, moment of RA with respect to the point A is 0. RA into 0. So, RA will not appear in the equation. That is the advantage of choosing the point A. Again, point B you can also choose. Same thing will happen. Okay, so in the equation, RA will not appear. Next one is the mid one. The total mass into G is equal to weight. That is the next force. Okay. In our engineering mechanics calculations, most of the people use the convention that anti-clockwise moments are taken to be positive and clockwise moments are taken to be negative. Again, it is your choice. You can follow the opposite convention also. Result will be same. There will be no change in result. But for a given problem, you must stick to a fixed convention. Okay? In the same problem, if you use different conventions, then there is a chance of mistake. So here, what I am doing here, I am taking anti-clockwise moment to be positive and clockwise moment to be negative. So this is point A, is the downward force through the CG. So with respect to this point, this moment is what? Clockwise. This moment is clockwise. So we have to put a negative sign. What is the moment? Total weight is 300 into G multiplied by the distance. Length of the beam was not mentioned. Say length of the beam is L, small l. Then L by 2 is the distance, perpendicular distance from this weight up to point A, L by 2. So L by 2 into 300 G with a negative sign, right? So minus L by 2 into 300 G. Means this becomes what? 150 G into L. 150 G into L. Then you move to the last point, last force, which is acting through the point B in the particularly upward direction, reaction RB. And this is anti-clockwise. This moment will be anti-clockwise, okay? So, with a positive sign, we have to write this one. According to our convention, according to my convention, okay? So, RB and the length is what? Perpendicular distance is the total length, L. So, plus L into RB. So, this is the algebraic summation. RA into 0 minus 150 G into L plus RB into L is equal to 0. So, first term vanishes, RA into 0 is there. First term vanishes. Then L is common in both the terms. So, you divide both sides by L. What is there in the right side? Algebraic summation must be 0. So, in the right side 0 appears. So, you divide both sides by G. So, what is the resulting equation? The resulting equation is minus 150G plus RB is equal to 0. Then RB is equal to what? It is 150G. RB is 150G. Now, equation is in your hand. RA plus RB is equal to 300G. Then RA is equal to what? RA is equal to 300G minus RB is equal to 300G minus 150G is equal to 150G. So, you have got RA and RB both to be 150 into G. You must write the value of G, 9.8, and then multiply it. 150 into 9.8, whatever be the result. You must put the unit also, Newton. Okay? Then your answer is complete. Don't leave your answer like 150 into G. Okay? So, in the next lecture, I will show you. So, this was rectangular. This is the simplest case for distributed load. Rectangular, okay? Load distribution was rectangular. This was the simplest problem. In the next class, I will show you the same problem for a triangular load. For a same problem, for same type of problem, but the load distribution will be triangular. In the next class, I'll show you that thing. Okay. And if you have any doubts, you must write in the comment box. In YouTube channel, there is comment box. Okay. So you must write if you have any queries regarding this class, regarding this lecture. If you have any queries, you write in the comment box. I'll try to answer to your questions. Okay. And don't follow any book, any textbook, or any teacher blindly. In the last class, I made a small mistake. Okay. So whenever you find any mistake by any teacher, you must mention that mistake, so that I can get a chance to rectify my mistakes. Okay? Thank you. Have a nice day.